So we'll start the session now. So in this week or today's tutorial session, we'll be dealing up with the week 9 lecture sessions. Right. So I'll share the screen first. So hello everyone. I'm Balram Shah. I'm the PMRF TA for this course, that is Watershed Hydrology, by Dr. Rajendra Singh from IIT Kharagpur in the Department of Agricultural and Food Engineering. So I'm doing my PhD at Interdisciplinary Center for Water Research at Indian Institute of Science, Bangalore. So as mentioned, today we'll be discussing about the week 9 lectures. So if you guys have any questions or any queries about the week 9 lectures, you can ask. Or if you are facing any trouble in the assignments before that weeks, also you can write to me in the forum in the NPTEL forum, right? Okay, so with that, we'll start the session. I'll stop this screen sharing here and I'll start somewhere else. Let me just and I'll also switch off the video just to have proper bandwidth. Yeah, okay. So join from here. Okay. So before this week, what all we have discussed, as mentioned before, also in the tutorial session, in the last tutorial session, I mentioned that all the understanding or the basic physics of the hydrology we have discussed in the previous lectures, and now we are moving towards the application of the hydrology or application of whatever we have learned till now in the watershed hydrology course, and hence some of the part of the lectures which you will be seeing, you might have seen those in the earlier lectures also, and hence it will be easier for you to understand that how you can comprehend and how you can relate the applications with the physics that you have, or the hydrology understanding that you have studied in the previous lectures, right? Okay, so with that, let us go. Okay, starting with this, so in this week, what all we have seen, we have studied about the floods, right? So what are floods? How floods are happening? Then what are the consequences of flood? How we can design some of the structures that we need to uh, control the flood kind of situation, or not control, but to manage the flood situations. And then we have also seen how we can do all the methods that are there for this kind of management practices, and so on. Okay, so we'll be starting with that. So can anyone tell what is flood, right? I hope you guys have gone through the lectures, right? So what is flood? Just by the word, what you understand, what is flood? Anyone? So flood, like if you see in the perspective of our areas such as urban area or semi-urban area, In that case, we can tell that floods are the most frequent type of natural disaster that we see every year in some of the portions of the world, right? So what are floods? When some high waters uh, elevation is there. So let's say whenever the water level increases, or there is a high water stage in which the water overflows its natural or artificial banks onto the normal dry land, or such as, let's say, river or something like that. When it inundates the plain, then we call that as flood, right? So what are floods? Those are high water stage in which water overflows, right, from its natural condition or natural behavior, let's say, right? So, as it is one of the most frequent kind of disaster, and we, the people in urban areas, rural areas, or semi-urban areas, are most affected by this. So, there are several rules and regulations. There are several reports. There are several works that has been done and is going on in the perspective of flood. Right. So, according to the World Disaster Report, if you see by 2000 in the 2018 or 2008 or 2017, what you will see that floods almost in the uh, all the natural disasters that you see are including droughts, including tsunamis, including earthquakes, and so on. Floods accounts for 41% of all the known natural disasters, all the known disasters, right? So this has affected a lot of people. As per some of the reports, it is around one third of the estimated 2 billion people are affected by natural hazards. Right? And India, India is one of the most severely flood affected countries in the world. And for let's say India, you know that CWC, or the Central Water Commission, has also Central Water Commissions will give you the data regarding the flows, or some meteorological or the hydrological data, right? So based on the flood damage data from 1953 to 2017 in India, the Central Water Commission has reported that floods will inflict damage worth rupees around 5,000 to 6,000 crore rupees annually. So you can understand how big economic loss we face just with a flood in one year, right? So with that, let's now we are clear with what is flood, right? Now we'll move to what are the types of flood. Okay, so flood can be classified into several classification based on what are the situation in which this flood is happening, right? So floods are riverine flood, coastal floods, then flash floods, urban floods, then glacial, lake outburst flood. This is also called, or this is abbreviated as GLOF. Now, if you write floods, then it will have S in it. Okay. So first kind of flood is riverine flood. From the word only, you can understand that when, uh, let's say when um, uh, ample amount of rain is happening, or when extreme rainfall is happening. Now let's say this is a river. Okay, water is flowing something like this, and this is some area adjacent to this river. Okay. Now when the water will fall in this side, then what will happen? When heavy rainfall will happen, this area will keep on increasing in this both the bank sides or the adjacent sides, right? In that case, what is happening? We are having the overflow of rivers, right? So because of this overflow of rivers, which happened due to the excessive rainfall, or let's say if it is a snow-fed rivers, then snow melt, or let's say snow, rapid snow melt. Okay, or any combination of several other factors. We have seen that how stream flow or runoff can increase, right? So the riverine floods happens when there is a overflow of rivers. So it will affect, firstly in the first instance you can say that what it will affect the river banks, right? It will affect the river banks as well as the floodplains. So the plain near to this till which flood can happen, kind of, we say that as floodplain. So this riverine flood mostly affects the river banks and the floodplains, which cause a gradual increase in the water levels, right? So India is highly susceptible to the riverine floods, Ganga rivers and some other. So due to the significant sediment load carried by the rivers from catchments and their inadequate carrying capacity, right? So this one was riverine flood. Next is the coastal flood. From the word you can understand that uh, it involves the overflow of seawater into the coastal regions, because in coastal region what you will see, there is sea on the coasts, right? Now sea, it has salt water, and hence when the overflow of seawater happens into the coastal region, it can cause widespread damage, right? And what are the causes? Anyone can say, can anyone say what can be the causes for this coastal floods? So mostly for any flood, you can say that a surge of the storms or heavy rainfall can be a cause. Other than that, for coastal flooding, you can say the high tides that happens, or maybe some cyclones or some hurricanes which happen, it will lead to inundation of the coastal areas, and hence coastal flooding happens. Right. So in India, for India only, you see there are a big coastline we have, starting from Gujarat, Mumbai, somewhere there, and then passing through Karnataka, Kerala, and then Tamil Nadu, Odisha, West Bengal, and so on, right? And other than that, we have union territories like Andaman, Nicobar, Lakshadweep, and all, right? So if you just add all the coastlines, you'll get around 7,500 kilometer of coastline just for the Indian region, right? And hence, it is classified under the high coastal flood hazard category because we have a very big coastline, right? And hence, our region is called in the category of high coastal flood hazard. Okay, that was the coastal flood. Next is the flash flood. From the word flash, you can understand that something which is happening very quick or very sudden, we call that as flash flood, right? So flash floods are characterized by a rapid rise and fall in the water levels involving high discharge. So mostly these flash floods happen in the uh, not only in the urban areas, but uh, it happens in the urban areas as well as some other riverine areas also. Okay, so these events cause significant damage to their suddenness, particularly in hilly regions where heavy rainfall, thunderstorms, or cloud bursts are frequent. So in the hilly regions also, flash flood situation are very common. Okay, so this one was the flash flood. So what can be the reason for flash flood? As I said, for hilly regions, if you see, most of the causes are heavy rainfall or thunderstorms or cloudburst. Other than that, if you just see, it can be because of the sudden water release from the dam or maybe upstream reservoir. Then, if there is any breach in the landslide dams, or if there is any failure in the embankments, all these things can lead to uh, flash floods, and it will lead to uh, uh, like impactful consequences, right? So we are done with riverine, coastal, and flash flood. Next we have urban floods, right? So urban flood means what? uh, as we know that our population are growing worldwide, and hence if the population is growing, we are more susceptible to move to the urban areas where we have most of the things like buildings and all, right? So as we are getting more flourished, so our susceptibility to be in the river or water related regions, like where we are, uh, water is very much we are very much with the water, like nearby we have water structures and so on. Okay, so unfortunately, we don't have that many regulations and controls. There has been significant encroachment along the floodplains, and hence, whenever extreme rainfall happens or when there is proper drainage is not there, because of all that, we face urban floods. Right. Next, we have glacial lake outburst flood. Right. So you guys know about the glacial lakes, right? So this glacial lake outburst floods are is a sudden and potential catastrophic flood that occurs when the water stored behind a glacier is released rapidly. So let's say a glacier is there where we have a big amount of ice, sand, or pebbles or debris are stored. Now, because of, let's say, climate change or because of some other reasons, if this is melting and uh, it is released rapidly in the downstream side, then this kind of phenomena is called glacial lake outburst flood. Okay, so when these glaciers store large quantities of bound water and then a sudden release of this water happens due to the melting of ice blocks, we call that as gloves. Okay. Okay. So with this, we are done with the types of flood. We'll do some questions and then again we'll come back here. Okay. So the first question is, which type of flood affects the river banks and floodplains? Anyone? So I just mentioned in the beginning only, right? So the flood which affects the river banks and floodplains is the riverine flood. So correct option will be A. Okay. If you have any question, you can just stop me there and then we can take a session. Okay. So the next question is, sorry. Yeah. So the next question is, which type of flood involves the overflow of seawater into the coastal region? So when the salt water or the seawater comes in the coastal region, we call that as coastal flood. So the correct answer will be B. Right. Okay, let's move on to the next question. The next question is, a flood that rises and falls quite rapidly with little or no advance warning is called a, anyone? Any guesses? So we call that as flash flood. But the correct answer is A, right? Okay. Next question is, flooding along rivers is known as, so yeah, flooding along rivers is known as, it's the same question. So it is called as the riverine flood. Option B, right? Okay. Next question is, coastal flooding occurs due to. Can you tell me? I will just explain few minutes back. So high tides can affect can cause the coastal flooding. If cyclones are there, it can also cause coastal flooding. And storm surges. This means if there is a surge in the storm, we can call that. No, that can also cause coastal flooding, and hence all these three will be the answer. And hence all of them will be the answer. Option D. Any question here? Okay. Next question is, the flood experienced by Brahmaputra river basin is due to. So mostly in the Brahmaputra region, if you see what will happen, the if you see the Brahmaputra river, it is a very large river, right? It flows through several states, and obviously it flows through one country to another country also, and hence because of the heavy rainfall, then because of the seismic activities and vulnerable hills, the Brahmaputra river basin mostly gets the floods. Hence, the correct answer will be all these three. Okay. Got it, right? Yeah. Okay. So the next question is. Okay. So before this, we'll just go through the some of the concepts again. So yeah. So now we'll move to the causes of floods. So while explaining the types of flood, mostly I have covered the all the parts of causes of flood. So can you guys tell me what are the causes of flood? Firstly, we have heavy rainfall. That is the first and foremost cause of flood we see everywhere in all the kinds of flood, right? Next is storm surges. So let's say if tropical storms or hurricanes or cyclones, particularly in the coastal areas, it can cause storm surges leading to coastal flooding. We have just seen in the coastal flooding, right? Next, we let's say if the river is a snow-fed river, then snowmelt can also cause the flood, right? Next, we have river overflow. Then urbanization, obviously. So not only urbanization, you might have also seen in the last lecture that let's say if we remove all the forest when we were discussing about the land use land cover effects, right? So in that you might remember that when we have seen that if we remove all the forest or all the trees from one area and we make it just a bare soil, then it can lead to 20 to 40% change in the runoff, right? So that can also lead to floods, let's say. Okay, so urbanization is one of them. Next, we have deforestation. Yeah, just now I mentioned deforestation. Then other factors also, right? Uh, which all we have discussed in types of flood. So all these can cause floods. And with this, like why we are studying these floods this much? Because it's just so. What are the consequences of flood? Firstly, the loss of lives, because that is the most important thing that we need, right? Next, the property gets damaged. Anything other than this, can you tell anyone? So our lives, we see so many lives are lost due to floods. Then we also see property damage. Then we also see because of all this there is a huge economic loss. In the beginning only I said mostly we face around 6,000 crores of loss in the economy just because of the floods annually. So economic losses, sorry, psychological and social impact. So when these kind of floods happen and the people who faces this kind of floods, they get a lot of trauma because they might have lost some lives in their family. They have lost all the properties they have like gained from all these years, right? And others because of all these situations they can face some trauma or stress caused by these floods, and it can have a very long lasting psychological effects on individuals, and not only on individual, it can also affect one whole community, right? So there can be a psychological and social impact also. Other than that, so let's say if some area is getting affected by flood, all the people who are there in that area need to be displaced, need to be moved to a new location, hence displacement of people. And because of this kind of floods, all the water that is there gets mixed up, and not only waters, the chemicals that are uh, like the chemicals that are mm, what to say the chemicals which are uh, ex, ex, the chemicals which are given by the households or industries, something like that, those also gets mixed up in the water, and hence all the waters that are there can carry pollutants, chemicals, sewage, So all the water, so we have drainage, storm drainage, and also wastewater which are getting flowed in the drainage basin. So those are different drainages, right? But in case of floods, what happens? All the waters gets mixed up. The chemicals which are coming from the industries, that also gets mixed up. The medicines that we are using, which need to be discarded properly, that's also get mixed up. And all these chemicals, pollutants, and this sewage gets mixed up, and hence it can lead to diseases. Because in that case, if you go to the rural areas which are getting affected, in those areas mostly people does not get a drinking water, which are like, say, if you go through the uh, guidelines of the drinking waters, the water that they are getting are not in the proper values. Okay, so which can lead to several waterborne disease and health issues for affect communities, and hence we are having contamination of water sources, isn't it? Anything other than this? So as I mentioned, it can increase the risk of diseases. Okay, so as you know that our country is a uh, most part is the most economy, or let's say most of the part is by agriculture. If this kind of floods happen in the agricultural areas, we have a huge impact on agriculture. Then several, sorry, disruption of services. So all the services in the location where the floods has been affected, you will see the electricity is not there for few days or maybe weeks or something like that. Communication is not proper, healthcare is not there. So all these services gets disrupted just because of the floods, and it can complicate rescue and relief efforts and worsen the challenges faced by affected communities. Okay. Other than that, we also get affected by the environmental. So just because of the floods, we can, or the environment can also have an huge impact. How? So let's say if flood is happening, then what can happen? Soil erosion can happen. Then habitat destruction, ecosystem can have a huge change in it. Then change in the composition of plant and animal populations and so on. Okay, so it can cause impact in the environmental impact, then the impact on biodiversity, and so on. So there are several other consequences if you see from the large domain to the smallest domain. Most of the thing is getting affected by the floods, and hence we need to study floods, and we need to understand how we can manage this kind of flood events. Okay, so in India, if you just see, it's a big country, right? And hence, if you just divide it, it will be a Brahmaputra region, then Ganga River basin, Northwest River region, then Central India, and the Deccan region. So all these are having, based on their characteristics, let's say their watershed characteristics, their topography, and so on. Based on their topography and so on, what we see, we have several flood prone areas in India. Okay, now we move to the flood severity assessment. So till now we are clear with how what are floods, how this flood can cause several havocs, what are the reasons, what are the causes for these floods, and so on, right? So, flood severity assessment means what? So, how severe is the flood? We have to assess that. Based on that, we can uh, create, or the government's officials, or some of the decision makers, how they can respond to these kind of flood situations. We need to understand that, and hence we do several assessments such as weather forecasting, because if we have a proper weather forecasting, we can tell that okay, in this region the flood, this much area will get inundated, or so on. Now how will we understand that how much area will be inundated or something? There are several models that we have seen. So in the earlier lectures when we were dealing with the hydrological models, in there we have seen that based on these hydrological models we can tell that how much is the area inundated, or some like how much would be the discharge and so on, right? So with that we can create the flood hazard maps, right? So how much area is inundated, if you see in the maps we can call that as flood hazard maps, right? So we use the remote sensing products to get to know that how it has affected or it is affecting. If we have real time data, it will help us, right? Then based on all this, what we do, if we forecast it properly, we do the early warning system. And hence with this early warning system, what we can do, we can inform the local communities that they have to relocate, or some other management practices we can use. Okay. Other than that, what we can do community reporting, so that they are pre known about how the local communities are often like can they can uh, help uh, in the region where the floods can get affected or the water levels are increasing and so on. Okay, so based on all this we have several classification systems. So we have several classification system. So what we do, we give, you might have seen in the news that there is a red alert, or there is a yellow alert, orange alert, or something like that, isn't it? So these, all these color code tells you something about the flood. Okay, so yellow code means what? Yellow code means that an established gauge height which when reached by a rising stream or lake or reservoir, it will represent the level where the action is taken in preparation for possible significant hydrological activity. And hence this is kind of like just to inform you. Next we have orange code, or orange code means that there can be a minor flooding, or there is a minor flooding. So if there is a minimal or no property damage, but there is like possible is there that there is a public threat, for example inundation of roads or something, then we call that as minor flooding, or there is a orange alert in the area. Next we have red alert, right? So red alert means there is a moderate flooding. This means what? That when some inundation of structures and roads near the stream happens, but evacuations of people and or transfer or property to the higher elevation happens, in that case we call that as moderate flooding, and hence we go for red alert. Okay. Next we have purple purple alert. In purple alert, this means there is a major flooding that is going to happen, and that is happening. Okay. And how the major flooding is defined? Major flooding is defined as an extensive inundation of structures and roads, significant evacuations of people and or transfer of property is needed to higher elevations where there is a safe place kind of. Okay. So with this we'll move to some questions. Yeah, so we were done with that. So next question is, flood severity assessment can be done from which of the following? Anyone? So just now we have discussed that the assessment that we do to understand the flood severity, in that we need to know that how we can map the flood plains. Then we need to do hydrological modeling, or mostly we do. Sorry, what happened? Give me a minute. So, sorry for the interruption. Yeah, I'll share it from here. Just give me a minute. Yeah, so from here first. Yeah. So what we were discussing was not this question. We were done with this. Yeah. So the question was, flood severity assessment can be done from which of the following? Any guesses? Anyone? Give a minute. You guys can. Any answers? Yeah. Okay. Yeah. I hope you guys can see the screen. Sorry for the interruption. Whatever we had. Yeah. So any guesses? So as I was mentioning, that you guys can hear the screen. Okay. So first one is the floodplain mapping, right? So we have to map the floodplain, then we have to do hydrological modeling, and also our early warning system is included in the flood severity. So correct answer would be D. That is all of the above, right? So the next question is red alert in flood severity assessment is classified as. So as we mentioned that the four classes that we have are yellow, orange, red, and purple, right? So purple we do mostly for the major flooding, right? Red alert we see when we have moderate flooding. Then we have minor flooding. We call that as orange alert, and yellow when just small action need to be taken. So for the red alert, when red alert is there, when we have moderate flooding, right? So the correct answer will be C. Next question is, what is the primary purpose of determining a design flood? So now we'll first discuss about design flood. So the word design, from this you might have heard if you might have gone through any structures or something like that. Mostly if we say that designing a structure, what we mean by that, we mean that we need to understand the dimensions or the design life or some kind of like how the structures will be, something like that. Okay, so now here the term is design flood. This means what? That flood design will refer to the process of determining the appropriate standards and criteria for designing structures to withdraw. Okay, I'll write that. So I was mentioning about flood design or design flood, let's say. So the process of determining the standards, let's say, for designing structures to withstand or manage flood events. To manage flood events, what kind of uh, structures do we have? We have dams, reservoirs, levees, and so on. Okay. So what is design flood? Design flood means the maximum flood that any structure which we have built can safely handle. Okay. So these structures need to be whenever we are designing these structures, we need to know like to give the dimensions of the structures and all. We have to uh, consider the economic factors, the hydrological factors, the climate factors, and so on. And based on all these, we design the structures. So there are several guidelines also. There are CWC guidelines. Then we have IS codes, okay, Indian Standard Codes, International Codes, and all. Okay. So, what are the procedure to select the flood magnitude? So, the most commonly used are the standard project flood. We call that as SPF, right? So, what is this standard project flood? In this, we estimate the flood based on the combination of meteorological and hydrological conditions, and which are mostly characteristics of the drainage basin being considered. But we are in this, we don't consider the extremely rare events, like if there is a very extreme heavy rainfall. So those kind of things we don't consider in standard project flood. But there is other thing called probable maximum flood. In this also, what we do, we estimate the flood based on the combination of both the meteorological PMF, right? Yeah. Both. So we estimate the flood based on the combination of both the meteorological and hydrological conditions. Only difference is, right, it includes the extremely rare conditions such as like extreme heavy rainfall or something like that. Okay, extreme rare and catastrophic floods. Okay, mostly this PMF we use to design the spillway, so that spillway design of the let's say very high dam is there. For those, if we want to design, we use this probable maximum flood procedure to design the structure. Okay. So what are the structures? Structures can be dams, then reservoirs, bridges, etc. Right. So as I mentioned, there are several guidelines based on like how much design flood should we select. So there are CWC guidelines in which you will see that based on how much or the what kind of structures we are dealing with. So let's say if you have a permanent barrage or minor dams with capacity less than 60 million meter cube, In that case, what we use the standard project flood determined by the unit hydrograph and the standard project storm, which is usually the largest recorded storm in the region. So let's say if you have a data for around 30 years, in that how much is the highest recorded storm. Based on that, what we do, we use the unit hydrograph and the standard project storm, and using the procedure of standard project flood, we get to know the design flood for permanent barrage and minor dams with capacity less than 60 million meter cube. Right. So other need things need to be considered are floods with a return period of 100 years for these kind of structures, or whichever, let's say in the two guidelines that I say to consider, in that whichever gives a higher value, we'll consider that for the design flood for these kind of structures. So any of the structures, if you consider that if it is a very big dam, so you, from your understanding only, you can say that it is a very big dam. It needs to have a good amount of design life, right? So based on that, how much is will be the design life and all. Based on that, we have several guidelines. For, let's say, for aqueducts, you will see for waterway, we take the design life for or sorry, not the design life, but for the return period as 50 years. For foundations of the freeboard, we take the flood with return period of 100 years. Like that, we have several guidelines. Okay. And in case of Indian standard guidelines, what we see that along with this category of how the structure is, whether it is small, medium, or large, how much is the gross storage, whether it is in a range, let's say, from 10 million meter cube to 16 million meter cube, or other than that, we have one more factor that is considered in this Indian standard is the hydraulic head. Like how much is the head from the datum, and if it is if the hydraulic head is from 12 meter to 30 meter, what kind of procedure we need to follow, something like that. Okay, so there are several methods to deal with this, or to design this design floods, right? So there are several methods, like physical indications of like how past flood has happened. Based on the past observations, we can design the flood, or based on the empirical formula, based on some data that we have. Then we have envelope curve built on for some regions, we can use that also. So we have overland flow hydrograph, we have unit hydrograph, then we also have rational method, then we have design storm, also we have flood frequency analysis. So based on all this, what we do, we do the design flood. Okay. So I'll not go in each of the methods, because it is very explained in very detail, right? So we'll just go through some of the equations that we need. Okay. Yeah. So one of the method is the rational method. Yeah. So in this rational method, you might have studied in the earlier lectures also, when we were dealing with the stream and runoff, isn't it? So in that, what we have seen that how, and as we are only dealing with the flood kind of situation, hence we will be dealing about with the peak discharge, right? And in the rational method, what we have seen, how we are calculating the peak discharge. Let's say we can Qmax, we get that as QP. QP is the peak discharge, is equals to CIA, right? Where C is a runoff coefficient. QP is the peak discharge, so we will take that as flood. This is in Qmax, or meter cube per second. Then what is I? Can anyone tell me? I is the mean intensity, mean precipitation intensity. Precipitation intensity for duration equal to or greater than the time of concentration. This one will be in meter per second, and A will be in catchment area in meter square. Okay, so we have seen this rational formula before, and hence this much detail is enough for you to calculate, right? Yeah, so we'll go to some of the problems first. We'll see. So unit hydrograph and all we have discussed in a very great detail when we were discussing about the hydrographs in one of the weeks, right? Yeah, yeah. So the question is, what is the primary purpose of determining a design flood? So the options are to assess the amount of water that will be used in irrigation, to design the flood control structures such as dams or levees, to calculate the water distribution in a river, or to estimate the annual runoff rate. So just now we have discussed. So we do this design of flood to design the flood control structures. Right? So the correct answer will be B. Correct. Okay. Next question is, what is the return period of a design flood? So we have also discussed about what is return period. We are not going to again discuss that in detail, but yeah. So in brief, what is return period? Return period is the average time that let's say there is a probability of some rainfall that can happen. So let's say we are considering one event, a rainfall of greater than 1,000 millimeter for 1 year for a specific location, and we want to know that what is the average time that that event will come again after some years, right? Remember that is a average time, so it does not mean that, let's say, if the return period is 20 years, this means after 20 years only it will come. It can be possible that in 200 years, in the like frequent 2 years it can come, right? So the return period is the average time that can average time which can be there between two events. So in case of the design flood, it will be flood events, right? So in this case, what are the options? Let's say first, the number of years it takes for a flood to return to its original state, right? Next option is the average time between the occurrences of a specific flood event or flood magnitude, the time it takes for a river to reach its floodplain, and the duration of time it takes for a flood to dissipate. So from this we can see that correct answer will be B. Okay. Any questions till now? Any questions? Okay. We'll move to the next question. The term 100-year flood refers to the largest flood that occurs once every 100 years, a flood with a 1% chance of occurring in any given year, a flood that occurs once every 10 years, a flood that can only be estimated for a 100-year period. So the correct answer will be this, a flood with 1% chance, because it would be, so 100-year flood means the return period is um, 100 years. So P is equals to, we know, 1 by P is the probability, right? Probability or the chance, you can see. So here it is 1 by 100, that is 1%, right? The correct answer will be a flood with a 1% chance of occurring in any given year. We call that as 100-year return period flood. Okay. So the next question is, the similarity in the standard project flood and the probable maximum flood is. So we have just now discussed about what is standard project flood and what is probable maximum flood, right? So these are the procedures which we generally use to design the floods, right? So what are the similarities? The first similarity is that both, we know that we use these procedures to estimate the floods which can occur with a combination of meteorological and hydrological conditions. Okay, so the similarity is that, and what is the difference? The difference between the standard project flood, which we call as SPF, and PMF. What is the difference? Just to know that you have listened properly. So the difference is that in standard project flood we don't consider the extremely rare combination, but in probable maximum flood we do, and hence in probable maximum flood we consider the extremely rare and catastrophic conditions. Also, we use probable maximum flood to design the spillway capacity or spillway openings of very high dams, right? So the similarity here will be the flood estimates occurs from the combination of meteorological and hydrological conditions, right? We'll move to the next question. For aqueducts, the recommended design flood return period should be. So while dealing with the CWC guidelines and the Indian standards, you might have seen that for aqueducts, we generally keep 50 years for aqueducts having the, not the waterways, for waterways you remember that we have considered for 25 years return period, but for foundations of freeboard, for foundations of freeboard we consider 100 years return period, but for the aqueducts waterways we consider 50 years return period, right? Okay, so let's move on to the next question. Next question is, the term included in IS guidelines when compared to CWC guidelines is, yeah, so the additional term, the additional term included in the IS guidelines when compared to CWC guidelines is storage. Anyway, you have might be seeing in both the IS guidelines and CWC guidelines. Design flood, obviously we are doing that. So the correct answer will be hydraulic head. So in IS guidelines, we'll see one more factor and that is added in addition to that of the CWC guidelines is hydraulic head. Okay, so the correct answer is A. The next question is, watershed area of 90 hectare has a runoff coefficient of 0.4. A storm of duration larger than the time of concentration of the watershed and intensity of 4.5 centimeter per hour will create a peak discharge of. So see, you have a runoff coefficient, you are given with the area and you are given with the intensity, right? So obviously you need to use the rational method. Okay, and according to the rational method, how you are calculating the peak discharge, we have seen that QP is equals to CI A, right? C is the runoff coefficient, so we have C is equals to 0.4. I is what? I is the intensity here. I is in 4.5 centimeter per hour, and A is the catchment area. It is 90 hectare, right? And for this formula, as it is an empirical formula, you remember that we have to give whatever units that are mentioned there. So the unit for intensity, it is meter per second. The area should be in meters square, but for here anyway the uh, units are matching the issue, meter cube per second, right? So yeah, so I'll write qp equals to, can you just do it? I'll give you guys 1 minute and then I'll do it here. Just convert this centimeter per hour to millimeter per second and this hectare into meter square and just put it in the equation, you'll get the answer. Try once. Okay, anyone got the answer? No, I'll try once. So the runoff coefficient is how much? It is 0.4 into, we have intensity as 4.5 centimeter per hour, that is 4.5 meter per hour into 60 into 90 hectare, that is 98.4 meters square. Just do this, how much you're getting. Get something like 0.4 to 1.25 into 5 into 98.4. I'm getting somewhere near 4.5 meter cube per second. So the correct answer is D. I hope you guys also got the answer. Any questions here? If not, we'll move to the next question then. Yeah, so the next question is, a culvert is designed for a peak flow as QP based on the rational formula. Okay. If a storm of the same intensity as used in the design but of duration twice as large occurs, the resulting peak discharge will be, right? So what we know, the peak flow or peak discharge as per the rational formula is C into I into A, isn't it? Right. Now what it is saying, that the intensity is same but the duration becomes twice larger, right? Becomes twice. So here you can see that it depends on the intensity and the area, correct? So even if the duration is changing, the intensity is remaining the same. Okay, and hence the peak flow, what it will be, will it remain the same or it will get doubled or will it get half? Obviously it will not get squared anyway. So as it does not depend on the duration, if the intensity is the same, hence the, if we write QP2, then it will become CIA itself, right? So the correct answer will remain the same, that is QP only. Okay, any questions here? Okay, we'll move to the next question then. The next question is, for a return period of, okay, so for this we need to discuss flood frequency first. Okay, now we'll move to the flood frequency analysis. Okay, so flood frequency analysis, mostly we have dealt with this kind of things in the earlier lectures. Okay, but just to remind you guys, so how we get the some event xt we consider that as x mu plus k into sigma. Now this k is the frequency factor whose equations will differ based on what kind of probability distribution you are considering. Right, for normal distribution it will be simply the event minus the mean by the sigma or the standard deviation. For different distribution, if you consider Gumbel distribution or if you consider let's say any other extreme value distribution, maybe gamma distribution or log normal or logistical distribution or Pearson type 3 distribution or any kind of distribution, the frequency factor equation will change, right? And hence from this equation we will get the xt value. What is xt again? Can anyone tell me what is xt? Xt is the, so let's say if x is the flood event, then xt will be the value of flood for t-year return period. I'm not explaining the return period because we have discussed it several times, right? And x bar is the mean of the data, data is in the flood data, and sigma is the standard deviation of the data, standard deviation of the data, and k, as I mentioned, it is the frequency factor. Frequency factor. Okay, and this k or the frequency factor mostly depends on, if you see the equations and all, it depends on the return period t and on the frequency distribution or frequency distribution. So in case of flood, if you see in precipitation, you might be remembering that if you consider the extreme precipitation, I might have told you before that we consider the extreme value type distribution such as gamma distribution or log normal distribution, something like that. Similarly, in case of flood, if you see, the most commonly used probability distribution functions are commonly used distributions are normal distribution, but still it's not much used. Then we have Gumbel's distribution, which is one of the extreme values distribution. Then we have log Pearson type distribution, and so on. So these are the most commonly used, right? So in not just to revise, sorry. So just to revise, remember, if we draw a normal distribution, it will be something like this bell-shaped curve, right? This y-axis denotes the magnitude of the event, and this shows a sorry sorry probability. This is the probability, right? Yeah. Okay. So in the normal distribution, what are the parameters? Remember, these are mean and standard deviation, right? This is mean. This is the standard distribution, standard deviation. Like that, if you see the other distribution that we mentioned, that Gumbel's distribution, log Pearson type distribution, these also have these kind of parameters for log. Sorry, what was that? Log Pearson. For log Pearson, what are the parameters we have? We have mean, we have the scale parameter, and we have the shape parameter, right? So in this normal distribution, if you see mean is what? Mean is the location parameter. How? Can you tell me how? So if you can just visualize, so here the mean is this one, right? It can be 0 or it can be from anywhere else. Now if you change the value of mu, what will happen? It will, let's say only the mu is changing. What will happen? It will shift something like this. So it will be mu1 and this one will be mu2, right? So this means what mean is doing? Mean is changing the location of the distribution, isn't it? And hence this mu is the location parameter. Similarly, if you see the standard deviation in case of the normal distribution, so how much is the deviation or the range here? It is this much, right? Now this mostly this is 3 sigma. If you just see 3 sigma in each of the directions, so it will be 3 sigma plus minus 3 sigma. Okay. Yeah. So now if you see, if you say that the distribution that you are saying, I'll change the color. uh, so now this is having sigma 1. Now you are saying like sigma 2 less than sigma 1, so something like this will happen. Sorry, something like this. Why? Because now see, the whole distributions, you know the axioms that summation of the probability will always be 1, or the area under the curve will always be 1, right? Now if you uh, reduce the standard deviation, what will happen? The whole distribution should go, this deviation should be less, but again have this, the total area under the curve should be 1, the value in the y direction will be more, and hence the the shape of the distribution will change, and hence sigma will be the shape parameter. Now in the log Pearson, if you see, this is again the location parameter only, and the sigma is the shape parameter. Sorry, the sigma will be the scale parameter, and the gamma will be the shape parameter. Okay, so whenever you are going through some distribution, you should know that what kind of parameter it is. Like if you shift just that, how it will affect the distribution. So just to revise, we have gone through this. Okay, now just come back to what we were discussing. So let's say if you consider any variate. So let's say if X is a variate of random hydrology series, then the series of Z variate will be created by the. So let's say if a variate is X, then we are calling Z also as a variate, but with the log transformation of X. Then how you can write the ZT? So T is for any return period or any recurrence interval. Return period. So ZT is equals to, I'll write it here again. Zt is equals to z bar plus kz into sigma z. Okay, where kz is again the frequency factor. Okay, and it will depends on the moments like mean, side deviation, skewness, kurtosis, and so on. Okay. Other than that, we also had one more thing, was the confidence interval, right? So what is confidence interval or confidence limit? Let's say confidence interval, confidence limits. It helps in understanding that how much uncertainty is there in any of the distributions. So let's say this confidence limit concept offers a great way to quantify the uncertainty uncertainty quantification in flood frequency analysis, right? So it will represent a statistical range. So if let's say if we are saying the confidence limit is some value, then it will represent a statistical range around estimated flood quantities expressing the uncertainty associated with these predictions. Okay, so if we just say that okay, the return period value is magnitude will be this much, let's say 100 meter cube per second, that is just a deterministic value, right? Now it is very difficult to just say one value, and hence what we do, we give a probability distribution, or else we give one confidence limit. Okay, let's say the value will be 100 meter cube per second plus minus 10 meter cube per second. So it can be it can vary from 90 meter cube per second to 110 meter cube per second, right? So mm, that is where we use this confidence limit. Okay, so we'll do some problems now. Okay, so the next question is, for a return period of 1,000 years, the Gumbel's reduced variate white is how much? I'll give 1 minute to you guys. You guys can start try once. Just try once, and I'll give the solution, and then we'll see that whether it is matching or not. Okay, just to remind you that how we write the Gumbel's reduced variate, it is equals to minus ln of t by t minus 1. So we have seen these formulas in the earlier classes. That's why I'm not going how it came and all. You can just use this formula. T, what is T? T is the return period. Just put the value of return period here. T is given as 1000 years. Just put that and just let me know how much you're getting. Okay, I'll do it here. So yt will be equals to minus ln of ln 1000 by 999. Just calculate that, you'll get something like 6.9072. So the correct answer will be A. I hope you guys got the same answer. So the correct answer. This would be A. Okay. Uh, did you guys get the same answer? I'll calculate it once again just to see if I have done the proper calculation. Yeah, I'm getting correct, same answer. Okay, so the correct answer is A. Any questions here? Okay, next question is for an annual flood series arranged in decreasing order of magnitude, the return period for a magnitude listed at position M in a total of n entries by Weibull formula. We remember Weibull formula to calculate the flood frequency analysis, right? So there we calculate it using this formula, that is M by n plus 1. So there are several other formulas, remember. So some formulas was M by n, some was like, so they use the position when you arrange it in this descending order. So M is the rank or the position, and n is the number of data in the series, or the data series, right? So the correct answer would be B, that is M by n plus 1. Yeah. Next question is the general equation for a hydrological frequency analysis states that xt, the value of the variate with a return period of t years, is given by. So we know with the confidence interval, or you just see that we can write the variate as general equation xt is equals to x bar plus minus t into sigma. So the answer will be both this. Yeah. A hydraulic structure with a life of 30 years is designed for a 30-year flood. The risk of failure. Yeah, so uh, just to remind you of the formulas, write it here once. So remember what is risk? The risk refers to the probability of occurrence of a specific event multiplied by the impact, or let's say the consequences associated with the event. Associated. that event. And how mathematically we write the risk? Risk R is equals to, sorry, equals to 1 minus 1 minus 1 minus p to the power n, where p is the probability of occurrence, right? And we know that for n1 series we write p as 1 by t, whereas t is the return period, right? The next term comes is the reliability. What is reliability, anyone? What is reliability? Reliability is a measure of the, like, how much uh, we can trust the system or the structure in withstanding the extreme events. Okay, so I'll write the measure of the dependability of a structure in withstanding a specific event. Okay, so RE equals to 1 minus of risk, that is 1 minus p to the power n. If you want to write in terms of return period, it will be this. Okay, and there is one more term called safety factor, or let's say SF. What is safety factor? Safety factor is a factor applied to the design capacity of a structure to provide a margin of safety against the uncertainties and unexpected conditions. In any of the structures, if you might have seen, let's say, our home or residential complex or bridge or highway or something like that, if you would have designed that, you consider one factor of safety, right? So that only we are considering here as safety factor. So let's say safety factor. Oh, shoot. Okay, it's not a minute. Can you guys see the screen? I hope you guys can see the screen. Yeah, okay. I was mentioning about the safety factor, right? So safety factor for any parameter m, how do you calculate? It is the ratio of the actual value of the parameter m, which is adopted in the design of the project, to the value of the parameter which we have considered to obtain from the hydrological consideration. Okay. Okay, so with this we'll do some questions. Here. Yeah, so the next question is, a hydraulic structure with a life of 30 years is designed for a 30-year flood. The risk of failure of the structure during its life will be how much? So we know we can write R bar is equals to 1 minus 1 by t to the power n, right? Where n here is the design life, that is 30 years, and t is the return period, that is also 30 years. You can just calculate 1 minus 1 by 30 to the power 30. Can you just calculate and let me know how much you are getting? I'm getting somewhere near 0.6383. Okay, yeah, so the correct answer will be B. I hope you guys are getting the same answer. Anyone? Okay. The next question is, a bridge is designed with a projected lifespan of 25 years, that is n is equals to 25 years. For a flood magnitude with a return period of 100 years, that is t is equals to 100 years. If 10% risk is deemed acceptable, what return period should be chosen? We know that R bar, so R bar is given as 10%. R bar is equals to 1 minus 1 by t to the power n. Okay, so what we need to find? We need to find out the return period. So this is the question. So R bar is given as 0.1, that is 1%, sorry 10%. And so we can write 0.1 is equals to 1 minus 1 by t to the power n is how much? It is 25 years, right? So it will be 1 minus 1 by t to the power 25 equals 1 minus 0.1, that is 0.9. That is, if you just calculate, see how much you are getting. 1 minus 1 by t equals to 0.9 to the power 25, right? That is 1 by t equals 1 minus 0.9 to the power 25, and t you will be getting as 1 by 1 minus 0.9 to the power 25. Just calculate it. Let me know how much you are getting. I will also calculate once. I am getting somewhere near 237.78 years. Are you guys getting the same answer? Right. Now, if you just, you can also check that for this, that is 100 years return period, how much you are getting that is. That also you can check for the design type. But for a given 10% risk acceptable, the return period that we'll get is 237.78 years. That is near to 238 years. Right? So the correct answer will be 238 years. Okay. Any questions here? Okay, we'll move to the next question then. So the next question is, the hydraulic risk of a 100-year flood occurring during the 2-year service life of a project is. So 2-year service life, n is equals to 2 year, and return period is given as 100 years. Remember that we talked about 100-year flood in the beginning. The 100 year represents the return period of time, right? So the risk we need to calculate. Same, we have to just use that 1 minus 1 by t to the power n. How much you are getting? 1 minus 1 by 100 to the power. That is how much you are getting. Let's calculate. You'll get somewhere near 1.99%. The correct answer will be D. Any question here? Okay. Next question. So the next question is, a flood control structure having an expected life of n years, okay, is designed by considering a flood return period of t years. Now, when t equals to n and n tends to infinity, the structure's hydrological risk of failure in percentage is how much? Okay, so we know the risk is given as 1 minus 1 by t to the power n. Now, what is given? That t is equals to n. Then in that case, r dash will become 1 minus 1 by n to the power n, let's say. Okay. Now we are having that, given that n tends to infinity. In that case, you know that limit n tends to infinity 1 minus 1 by n to the power n is written as how? Can you tell me? Remember? Simple limits if you have might have studied in your 12th or something. It is given as 1 by E, right? And E we know E is somewhere near 2.718, something like that, right? 7828 something. So for that, you can write this as 1 minus 1 by E. It is 1 minus 1 by 2.71828. This will come near 0.632. It is 63.2%. Any questions here? So the correct answer will be D, that is 63.2. Okay, no questions? I'll move to the next question then. The next question is structural flood control methods does not include. So there are, okay, now we are done with the design floods. We move to the flood management, right? So in flood management, what we do, we have several flood control structures like structural flood control methods, then non-structural flood control methods. So this was explained in detail in the lectures, just to you guys can tell that which are the structural flood control method and which are not the structural flood control method. Right. So see here it is asking does not include, right? So drainage improvement in urban areas, we know that how we do the drainage improvement. We remove the clogs, we do some structures there, right? So that is one of the structural flood control methods. So this is one of the structural flood control method. Right? Dams and reservoirs are also one of the flood control structural one. Then watershed management and land treatment is also structural. But this is the non-structural. So what we do the floodplain zoning. Zoning, you remember if when we are talking about the dams and reservoirs, some dead storage zone, then live storage zone, then some freeboard we do, some extreme floodplain, flood zone, something like that. Because this is the non-structural flood control method. So the correct answer for this question will be floodplain zone. Okay. Okay. So there are several floodplain zoning anyway we have studied, and there are several